बिस्मिल्लाहिर्रहमानिर्रहीम। अल्लाहुम्मा सल्ली अला सय्यिदिना व मौलाना मुहम्मदिन व अला आलिहि व अस्हबिहि व बारिक वसल्लम। अल्लाहुम्मा रब्बि ज़िदनी इल्मा। अल्लाहुम्मा सल्ली अला सय्यिदिना व मौलाना मुहम्मदिन व अला आलिहि व अस्हबिहि व बारिक वसल्लम। आमीन। अल्हम्दुलिल्लाहि रब्बिल आलमीन। The topic of this lecture is summary of testing of hypothesis. You can find the link of the math website Math by Sir Qadri in the description, where you can find the soft copy of this lecture. You can also Google the math website. Learn and spread knowledge. Testing of hypothesis. Summary. Testing of hypothesis means a claim that we want to test. H0 means the null hypothesis. Null hypothesis means the current situation, whereas H1 means the alternative hypothesis. Alpha percent means the level of significance, whereas this small x means the test value. Types of tests. There are three types of tests. Number one, the upper tail test. Do it when H1 involves a greater sign. Number two, the lower tail test. Do it when H1 involves a lesser sign. And number three, the two tail test. Do it when H1 involves a not equal sign. Discrete distributions. This is the upper tail test. This C means boundary of critical region. And after this C, the region is known as the critical region or CR, or rejected region for H0. Here we reject H0. And this alpha percent is the probability of this region. And this is the accepted region for H0. Here we accept H0. In testing, there are two possible decisions. For example, if test value lies here in critical region, then we reject H0. And if the test value lies here in accepted region, then we accept H0. For example, if H0 is P is 1 upon 6, means the die is fair, and H1 is P is greater than 1 upon 6, that means the die is biased or unfair, and this is the claim. So we have two possible decisions. Number one, if the test value X lies in the critical region, here, if the test value lies here, then we reject H0 and we accept the claim, and we will conclude that the die is biased. And the second possible decision is, if the test value X does not lie in this region, means it lies here in this region, then accept H0 and reject the claim and conclude that the die is fair. Type 1 and type 2 errors. Well, a type 1 error occurs when a true H0 is rejected, whereas a type 2 error occurs when a false H0 is accepted. This is the region of type 1 error, because here we reject H0. So the probability of critical region will be the probability of type 1 error. And this is the region of type 2 error, because here we accept H0. A type 1 error occurs when a true H0 is rejected, and here we reject H0. Whereas a type 2 error occurs when we accept H0, a false H0 is accepted. You can also understand the meanings of type 1 and type 2 error with the help of this table. Originally H0 is true, and in testing, we have two possible decisions. Number one, if H0 is accepted, then the decision is correct and there will be no error, because originally H0 is true. And what if the second decision is H0 is rejected? I told you in testing there are two possible decisions. Originally H0 is true, and these are two possible decisions. Number one, if H0 is accepted, then the decision is correct and there will be no error. But if H0 is rejected, then the decision is wrong decision, and a type 1 error will be made. If H0 is false originally, again we have two possible decisions. Either H0 is accepted or H0 is rejected. So what if H0 is accepted? Then the decision is wrong, because originally H0 is false and a type 2 error will be made. And what if H0 is rejected? Then the decision is correct and there will be no error. Probability of type 1 error is the probability of the critical region, whereas probability of type 2 error is the probability of accepted region, or critical region, the complement of critical region. This is the complement of critical region. In discrete distributions, we find critical region by trial and error method. Continuous distributions. The upper tail test. This is the boundary of critical region. This region is known as critical region or rejected region of H0. Here we reject H0. And this is the probability of critical region, alpha %. This is the accepted region of H0. Here we accept H0. Again we have two possible decisions. So if the test value X lies here, then we reject H0. And the second decision is, if the test value lies here in this region, then we accept H0. Type 1 and type 2 errors in continuous distributions. I told you a type 1 error occurs when a true H0 is rejected, and here H0 is rejected. So this is the region of type 1 error. In continuous distribution, the probability of type 1 error is always alpha %. And this is the region of type 2 error, because here we accept H0. A type 2 error occurs when a false H0 is accepted, and here we accept H0. And the probability of this region is the probability of type 2 error is the probability of this accepted region. Critical region, type 1 error probability, alpha %, and probability of type 2 error is the probability of critical region complement, the complement of critical region, meaning this region, accepted region. Now, how to find critical region in continuous distribution? For critical region in continuous distribution, always use this formula. Z test is equal to Z critical. For example, if X is normally distributed with mean is mu0 and variance is sigma square, then with the help of this formula, we can easily find the critical region. Z test, critical region, boundary of critical region C minus this mu here, and standard deviation is here. What if alpha % is 95%? So this ZC will be 1.645. By solving this equation, we can find the value of C. Types of questions in testing. There are two types of questions in testing. Number one, populations, and number two, distribution of sample means. For distribution of sample means, you must be good at sampling. You may watch my lectures on sampling on the channel. In populations, number one, binomial distribution. X follows binomial with n number of trials and probability of success is p. For example, H0 is p 0.3, H1 is p less than 0.3. So this means lower tail test, and X is binomial, X follows binomial with n 20 and p is 0.3. So you have to solve this question through binomial distribution with the help of this formula. Number two, normal approximation to binomial distribution. This concept is from S1, and this is the condition for normal approximation to binomial distribution. Both NP and NQ are greater than 5. See, X is binomial and mu is NP and sigma square is NPQ. So X is approximately normal with mean NP and variance NPQ. And this is the formula for the value of Z test. You have to do the continuity correction. So X plus minus 0.5 minus NP here and under root NPQ here. You can understand this concept with the help of this example. Given H0 is p 0.6 and H1 is p is not equal to 0.6. This means a two-tailed test, and this is binomial. See, both NP and NQ are greater than 5 in this case. So you have to use the normal approximation here. And the test value is 20. Now, since this test is two-tailed, so you have to check the test value with respect to mean. Critical region is here and here. Now, if the test value is less than mean, like in this case, the test value is less than the mean, then you have to perform lower tail test in two-tail. As the test value is less than the mean, that is X is less than NP, so do this lower tail test. And for this test, take the upper bound of the test value. Because whenever we go in this direction, we take the upper bound. This is the way to do continuity correction here. See, take the upper bound of 20 plus 0.5, because you are going in this direction. So you have to take 20.5. Remember this case or this condition. If the test value is less than the mean, then always take the upper bound. Whereas if the test value is greater than the mean, then take the lower bound. But in this case, the test value is less than the mean. So we took the upper bound of 20 here. And this will give you the value of Z test. And you would need to compare this value with the Z critical. Number 3, Poisson distribution. X follows Poisson with mean lambda. If lambda is small, if lambda is less than 15, less than equal to 15, then always solve question with the help of Poisson distribution. Here you have to use this formula. e power minus lambda, lambda to the power x over x factorial, because lambda is small. Number 4, Poisson approximation to binomial distribution. And this is the condition of Poisson approximation to binomial distribution. N is greater than 50 and p is less than 0.1. So if in the question of binomial, like in this question, if n is greater than 50 and p is less than 0.1, then always use Poisson approximation to binomial distribution. This question will be solved with the help of Poisson distribution formula. Here you have to use this formula. Number 5, normal approximation to Poisson distribution. We do this when lambda is greater than 15, and this is the condition of normal approximation to Poisson distribution. See, x follows Poisson with mean lambda, so mu is lambda and sigma square is also lambda. So x is approximately normal, and you have to do continuity correction here. And the rule is same. If the test value is less than lambda, then take the upper bound, otherwise take the lower bound. Here lambda is 20 and test value is 25. Since the test value is greater than lambda, so take the lower bound, 24.5. So when the test value is greater than lambda, then take the lower bound. Number 2, distribution of sample means. For example, if x bar is normal with mean mu and variance sigma square over ns, ns means sample size, then this is the formula of z-test. X bar, test value, this mu is here, and this is mu naught, the value of h naught. This is here, and the square root of this is here. And you should go through my notes of sampling, and my notes are available on the math website to be good at this topic. I hope this lecture will help you to understand, to summarize testing. An important advice: be careful. All the best. Allah Hafiz.